kids, we're back after spring break. We are going to look at section 12.2. I'm going to try to talk pretty quickly because there's a lot in this section to talk about. You do have some familiarity with this section because you've done it in middle school, but this year in high school we're going to add some formulas in that you may not have used before. So to start out, I just want to show you a couple pictures of some prisms because we're going to be finding surface areas of prisms and cylinders. These are the body parts of prisms. We've talked about some of these body parts before. You probably know them. I'm going to point out the most important thing that you need to know about prisms, and that is how to find the bases. When you are finding the bases in a prism, you're going to be looking for the parallel congruent polygons that are usually not rectangles. So in this case, these are hexagons. So this is a hexagonal prism. They are not rectangles. They are parallel and congruent. If the prism is leaning over to the side and the sides are not rectangles, the lateral sides or the lateral faces, then that's going to be called oblique, but you'll still find the surface area and the volume later on in the chapter the same way. It's just that the sides will be parallelograms instead of rectangles. Okay. If you are interested in how we get these formulas, this section will show you. I'm going to jump into how to use them for time's sake, but in this section in your book, you can look at how they come up with the formulas. We're also going to be looking at cylinders, and cylinders don't have quite as many body parts, but they do have something called an axis that runs from the center of the circles and connects the center of the two circles. So again, if the cylinder is leaning, it's going to be an oblique cylinder. You'll find the surface area and volume the same way. If it's standing straight up and down, it's right. If you are interested in how to get the formulas, again, they're in this section. You can look at them. But we're going to jump into 4 examples, and you'll be able to pause these as you're doing them and be able to do them then in the workbook the same way. Okay. So like I was talking about, if you have a prism, we're going to assume that this is a right prism. You need to know who the bases are. So if it's a rectangular prism, then obviously you have different options for who the bases could be. You could use the top with the bottom, or the left with the right, or the front with the back. I usually choose the base that it's sitting on, so I'm going to choose this as my base. You have to figure out who the base is before you ever start the problem. Okay, so now we have these different variables. This is going to be the formula that we use for surface area for all of our prisms and cylinders. It's a P for the perimeter of the base, an H for the height of the object when it's sitting on its base, and a capital B for the area of the base. So what I want you to do on all these problems, you're going to be doing 6 problems. You're going to list out the variables to the side so that you can find them individually, and then you'll take them in and put them into the formula. Okay, the perimeter is always the perimeter of the one that you choose as the base, and those have to be congruent and parallel. So I'm going to choose the one it's sitting on. So it's going to be 9 plus 4 plus 9 plus 4 for my perimeter. So when I add all of that up, I'm going to get a perimeter of 26 for this base going around. The height of the object is always how tall it is when it's sitting on its base. So if it's sitting on its base, we know that this stands 6 feet tall. And then capital B is going to be the area of the base that you choose at the beginning. And so the area of the base is going to be the area of this rectangle, which is going to be 9 times 4, which is going to be 36. Now I know my variables, so I'm going to take them back up and I'm going to put them into this formula. Now in this formula, this is actually the area of the sides called the lateral area, and then this is the area of the sides plus the 2 bases, which makes up the entire surface area. We're just going to be finding surface area. You do not have to find the lateral area, except, lateral area is part of surface area, but you'll just find this whole total here. So we're going to do 26 for the perimeter. Take that times the 6, which is the height of the object. That gives you the area of all of the faces on the sides, and then we're going to add on the 2 areas of the bases because we have 2 bases. 2 times 36. Okay, you're just going to multiply all of that out and add it together, and you're going to end up with 228 square feet. And since it's area, remember it's square units. So the rectangular prisms are pretty easy to do, and keep in mind you could have used different bases, but really finding the perimeter and the area and the height is pretty easy on those. Okay, now we're going to step it up a little bit, and we're going to do a triangular prism. So we name prisms according to their bases, and this is going to be a triangular prism. So what you're going to make sure that you do is you've got to look for the polygons that are congruent and parallel and not rectangles. So in this case, my bases are going to be this triangle and this triangle. It's not sitting on its base, but I still have to use the triangle as the base. So I'm going to draw that triangle over here so I know that this is my base, and I'm not going to confuse it with the rectangles, because if I use the rectangles as the bases, the formula will not work. Okay, again, my formula is surface area is perimeter of the base times height of the object plus the area of two bases. This is the lateral area, which is the area of all three rectangles, and then we add on two triangles to get the total surface area. Okay, over to the side, I want you to list your variables out to the side, and you'll do this on your workbook page. Okay, so when I go to do the perimeter, it has to be the perimeter of the base, which is my triangle. So I come over here and I'm looking for my perimeter. I don't know it because I need to find this variable right here in order to have my total perimeter. So I could either recognize that this is a 45, 45, 90 and get 12 square root of 2, or if I don't recognize that, I can do Pythagorean theorem to get my hypotenuse. Now keep in mind, I'll let you use decimals on these. So even if you thought that was 12 square root of 2 and you want to type it into the calculator as 12 square root of 2, you may use a decimal for that just because we're on e-learning. So we're going to streamline it. So when I do Pythagorean theorem or I type this into the calculator, I get about 16.97. So I'm going to make it 17 because when I round to the nearest tenth, it will be 17. Okay, so now that I have the three sides, I can come back and find the perimeter. So it's going to be 12 plus 12 plus 17. So I'm going to add that total up, and I'm going to get 41 for the perimeter of the base. So I'll be able to use that for the perimeter of the triangle. Okay, H is height of the object if it's sitting on its base. So you have to picture you standing this straight up and down and sitting it on this triangle. It would stand 8 tall, which seems weird because 8 is on the side, but you have to picture standing it up on its base. It's the height of the object when it's standing on its base. And then capital B is the area of the base. So now I'm going to come back over to my base and I'm going to find my area. My area of the base is 1/2 base times height because it's a triangle. So now I'm going back to what I learned in chapter 11. 1/2 of 12 times 12 will be the area of my base. So when I do that, I get 72 for the area of the base. So I bring that over and write it in as the area of the triangle. Keep in mind the P and the B both go with the triangle because that's the base, and the H is the height of the object when it sits on its base. Okay, so now I have all of these numbers and I can take them and plug them into my formula. So the surface area is going to be the perimeter of the base, which was 41, times the height of the object when it's sitting on its base, which is 8, plus the area of the two triangles, which is 2 times 72. Okay, so when I multiply all of that out and add it together, I get 472, and the units are millimeters squared because it's area, surface area. Now, when you were little, on both of these questions, you learned how to find the surface area by adding up all the rectangles and the triangles. That method will still work. We're just trying to be a little more professional since you're in high school now and use a formula that is usually given to you on the SAT and ACT that you can actually find the different variables and plug them in. But yes, you can still find the area of the three rectangles and the two triangles and just add them together and you would get the same thing. Okay, so we're going to step it up to the last, most difficult example, and then we'll do a cylinder, which is pretty easy. Okay, this one is the hardest example, so you might have to pause this and use it to help you on your workbook. This is a regular octagonal prism, and the bases are octagons. And I wrote out my formula, so I'm going to do the same thing. I'm going to list my P, H, and B out to the side, which is also what I want you to do when you do these. Okay, the P is the perimeter of the base, so we got to decide who the bases are. So you're looking for the parallel and congruent polygons that are not rectangles. So if you look, these octagons are going to be your bases, and they are parallel, congruent, and they are not rectangles. Okay, so the perimeter is going to be the perimeter of the base. So over here, I'm going to draw out my base. So I'm just going to draw a quick sketch of what my base looks like. It's really bad. And then it told me that this was 6 inches, and I know my base is the octagon. So if I want the perimeter of the base, that's going to be 6 times 8 sides, which is 48. So the perimeter of the base is 48. I know that. The height of the object, that's easy because it's already given me that, is 11. And now I need the area of the base. This is where it gets kind of tricky because this is a regular polygon, and we know for the formula of a regular polygon we have to use 1/2 apothem times perimeter, which you guys did great on that on your workbook page. couple sections ago. Okay, so to get the area of the base, I'm going to have to drop an apothem, and I'm going to have to use 1/2 AP. So I put the 6 down here because I want to remember that it's split into 3 and 3 when the apothem drops. All right, I need to find this angle up here. So I'm going to be doing 360 divided by 8, which is 45, divided by 2, because this apothem splits that 45 in half. So this should seem familiar if you did that section on area of regular polygons. Okay, so that's 22.5. Now what we're going to do is put an X on the apothem. We have to find that. So this is the opposite and the adjacent. So I'm going to do tan of 22.5 equals 3 over X. And then I'm going to find the tan of 22.5. I'm going to solve this. So you know how to do that. I'm just going to go ahead and tell you that when you solve that, you can work that out if you want. That gives you 7.2. That means my apothem is 7.2. Now I'm ready to find the area. So area is 1/2. I'm going to take my apothem, 7.2, and then I need my perimeter of my octagon. Well, I already knew that from over here. That's 48. Okay, so I'm going to do 1/2 apothem times perimeter and get the area of my base. So the area of my base, once I do 1/2 AP, is, let's see if I can find it, 172.8. That should be the area of your octagon. Okay, so now what I'm going to do is bring that over here. And I've got all my variables ready to go, so I'm going to plug them into my formula. The surface area is, this is the lateral area, which are the areas of all the rectangles. The rectangles will be 48 times 11, plus I have 2 octagons, so I have 2 bases, so 2 times 172.8. When I multiply all of that out and add it together, I should get a grand total of about 873.6 inches squared, because we are dealing with surface area. That is by far the hardest example. So you'll have a hexagon that you will do like that on the workbook, where you'll have to do 1/2 AP also. Okay, so now I'm going to leave you with the last example, which is a cylinder. And the cylinders are pretty easy compared to the others. The only thing you have to do is when you list your P, H, and B, you've got to think about the bases as being circles. So now the polygons, these aren't really polygons, but the circles that you have are congruent and parallel, and they're not rectangles. So the perimeter, you're going to be using 2 pi r for that. The height of the object is still 18. That's how tall it would be if you stood it on its base. And the area of the base, you're going to be using pi r squared. So what we're going to do is we're going to take and plug in a radius. So if they show you that this whole thing is your diameter, you're going to be using 7.5 as your radius. So 2 pi 7.5 will be the perimeter. The area of the base will be pi 7.5 squared. And once you find those, then you can just take those easily and put them in. Now, it kind of depends. If they want you to leave it in exact form, we leave pi in. If they say round to the nearest tenth, we multiply it out. So I'm going to practice by leaving it in exact form. So my perimeter is going to end up being 15 pi. So this is 15 pi. And then I'm going to take that times the height of the object, which is 18, plus, and then when I type in 7.5 squared to find the area of the base and leave pi in, it's 56.3 pi. So I'm going to leave that as is, and I have 2 bases, so I need 2 of those, 56.3 pi. Again, I'm just leaving it in an exact form. So when I multiply this out for the lateral area and I add the area of the 2 bases, I get a total of 382.6 pi. If I times that out, I will get the approximate answer, and I can round that to the nearest tenth. I actually rounded it to the nearest hundredth and left it to the nearest hundredth, and then this would be millimeters squared because it's area. The cylinders you will find are pretty easy as long as you convert the perimeter of a circle to 2 pi r and the area of the circle to pi r squared. Okay, now the very last thing I'm going to show you is when you do your workbook page, I want to give you a hint. So anybody still watching this video will have a gigantic hint here. You're going to be doing 6 questions. I want you to cross out lateral area. You don't need to find lateral area, just the surface area of these. The lateral area is already in there. And then I want to point out that when you go to do number 4, you will be dropping a height down and making this 2.5 and 2.5. You will need to do Pythagorean theorem to find the height of number 4. That's probably one of the more challenging ones. Okay? Take care, and I'll see you guys next time.